Hi guys, today we're going to start going over section 7.3, really just covering slope fields. So the objective today is to, that was from yesterday, estimate solutions to differential equations, and it's still what we're doing. So the goals. A slope field is a graphical representation of a differential equation on a finite set of points on the plane. And these slope fields provide information about the behavior of solutions to first-order differential equations. And so I think it's pretty, this topic as a whole, I think is a pretty visual one. Like once you see it, it makes sense. But yeah, so we're going to be drawing what that differential equation would look like, just so that you could help you find what an estimate of that equation could be when you can't actually find a real solution. And then if you were taking the BC exam, or in your college courses, you would learn this and you'd learn Euler's methods, but we're not doing that. So yeah, so direction fields, like I said, they're best learned visually. I'm going to try to explain them verbally though. So if the equation, when we say y prime, right, if the derivative is x plus y, then we could say that the slope is the sum of 2 points, right? So at 0, 1, the slope, and I'll write that down. Let's see. So if the equation is x plus y, we could say at the point 0, 1, the slope, which is the derivative, would be 1 plus 0. And so we could, estimate what that looks like. And so it tells us the slope, and then we can draw the tangent line for values close to the point as a short line segment. And then we kind of repeat this process for every point on the graph, and we call that a slope field. And they give you the direction in which a solution is heading, and allows you to visualize like the general shape of what differential curves look like. So we're going to do one together. So example 1 says sketch the direction for the differential equation y prime equals x squared plus y minus 1. Then use this to sketch the solution curve that passes through the origin. So the first thing I'm going to do is find the slope. And so, right, I'd be saying this is equal to -2 squared plus 0 squared. Murphy, stop barking. -2 squared plus 0 squared minus 1. So I get 4 minus 1. So at the point -2, 0, I got 3. At -1, 0, I'll get 1 plus 0 minus 1. I would get 0. Right, 0 plus 0 minus 1. I'd get -1. Same here, 1 plus 0 minus 1, I'd get 0. 2 squared, so 4 plus 0 minus 1, I get 3 again. Let's scroll down. For -2, this is that 1. Okay, so -2 will be 4 plus 1 squared, which is 1, minus 1, we get 4. We have 1 squared, right, -1 squared is 1, plus 1 minus 1 gives you 1. 0 plus 1 minus 1 gives you 1. 1 plus 1 minus 1 gives us 1. Oh, sorry, this one will give you 0. And this will be 4 plus 1 minus 1 gives us 4. So now we know what the slope is at all of these points. And so we're going to go ahead, let me move this. We're going to go ahead and make this into a graph. So it looks like and on the AP exam, and even on the homework questions, you'll see they're all free response questions, but they actually give you the graph. You don't have to make one like this, right? So this would be like -1, -2, -3, -4. On your AP exam, make sure that you're labeling at the very least the origin and your x and y axis. Right, we can't ever make the assumption that the grader or the reader just knows what it is, because that's what it is in math, right? That's what it tends to be. Make sure you're labeling everything. Okay, so then we said at the point -2, 0, we have a slope of 3. And so then you want to think, if I were to go forward 1 point, right, it would go up 3 places and over 1. So this line here is going to be towards that. But you won't have you won't have a ruler at all. You can't use one on the test, and you don't have time to use one anyway. So estimate, but make sure that these lines don't run together when you put them all in. So -1, 0, we get just 0. 0, 0, we get -1. Okay. 1, 0, we get 0. 2, 0, we get 3 again. -2, 1, we get 4. And so just making that one steeper than that one, I hope. -1, 1, we got 1. So -1, 1, we said 1. 0, 1. We got 0. Here we got 1 again. Oops. I don't know what's going on there. We can try to erase it. Okay. So, out. Again. Okay, so we're at 1, 1, and we got 1. We're just going to give up on this pin. So 1, 1, we get a value of 1 for the slope. So again, pretending that I could go through that line like that. And then 2, 1, we got 4. So much more arched. Okay, and so this is a very small slope field in general. Okay, so I've gone ahead and I filled in more of this map so that you kind of get a clearer picture than just the bare bones of what this function would look like. And then what you're going to do, right? So step 1 was we're going to sketch the direction field, and then we're going to sketch the solution curve. Okay, so the solution curve tells you what does a possible solution look like to the function, to this differential equation. And what you do is you're just going to take a point and you're going to go parallel. So I'm going to start at 0, and we're going to pretend I actually can draw too. Well, start at 0. I'm just kind of following the direction of these lines, and I will say these lines are supposed to be almost vertical, but it is what it is. So, we're following these lines here and trying to see the same thing. Maybe if we went here and then following this could be one solution set. You couldn't even start, like here and draw another one. It just means filling in these other points, right? Like obviously these aren't really going to be solution sets, because as you get far away, like you're basically just dealing with a line. Pretend that line's straight. It's not. But yeah, so this is the solution curve, and this is my slope field, everything else in between. And that's pretty much it. And the free response question, it'll have you do the slope field, draw the sketch curve, and then probably verify, a solution that they give you. So you have 2 free response questions for homework. But that's it, guys.